Ida Dubiri from the ITU, the International Telecommunication Union, and I have the privilege of introducing today's webinar. ITU is the United Nations specialized agency for ICTs, and we are also the organizers of the AI for Good Global Summit, alongside the X Prize Foundation, in partnership with 36 UN sister agencies, ACM, and co-convened with Switzerland. The goal of the summit is to identify practical applications of AI to advance the Sustainable Development Goals and scale those solutions for global impact. The AI Summit has gone digital with weekly online programming, allowing us to reach even more people all throughout 2020. We are pleased today to host this webinar on AI and aviation with ICAO, the International Civil Aviation Organization, who is also one of the UN sister agencies participating in this year's program. We have a distinguished set of panelists today, but we're counting on you, the participants, to help create an engaging discussion. For this, we will be using the Q&A functionality, which you can find just left of center at the bottom of your screen. In addition to the Q&A, we will also be using the chat functionality. Please make sure to set the message recipient to all attendees and panelists, not just all panelists. You can select this option just above the message box. Now, before we turn to our panel, I would like to ask everyone to try out the chat functionality and let us know where you're coming from, which country or which city. So I will type myself, pressing the chat button, and I will send to all panelists and attendees, Geneva, Switzerland. So please feel free to send your message, and telling from our previous webinars, we've had people from all around the world. We have Ukraine, France, Brussels, Spain, Dubai, lots of different places. So that's great. We're happy to have you on board today. So without further ado, I would like to introduce today's facilitator, Maimouna Taljak, who is the Secretary of the Airworthiness Panel and a Technical Officer at the International Civil Aviation Organization. Over to you, Maimouna.
Okay, let me try to get this video on. There you go. Okay, so that works very well. So thank you so much, Ida and the ITU team, and welcome everybody to our session on AI, meaning artificial intelligence in aviation. My name is Maimouna Taljak, Technical Officer, Airworthiness at the International Civil Aviation Organization, which I will abbreviate as ICAO, and I will be your moderator for the next hour or so. So this webinar is part of a series of the AI for Good Global Summit, which is virtual this year. And as said in the introduction from Ida, throughout this panel session, you will be able to interact. So feel free to ask questions, to use the chat function, and to ask as many questions as possible, because we want this to be interactive. So we have a very distinguished panel this morning for you. Their bios can be found on the AI for Good Summit website. I will introduce them the way they will be presenting, the way they will be making their presentations. And while each and every one of them deserves a genuine introduction, in the interest of time, I'm not going to go into much detail. I will start by asking them where they are calling from, what they do, and what's their favorite dessert. I know my favorite dessert is chocolate cake. So let's start. I will start by introducing Paul. So Paul, say where you are calling from and what you do and what is your favorite dessert. Over to you, Paul.
Hola, boom. Thank you, Mina. So my name is Paul Bosman. I work for Eurocontrol. I am the head of an operational division looking at the infrastructure in Europe, and my favorite dessert is vanilla cream.
Wow, nice choice. So next I'll go to Marco. Marco, please tell us where you are calling from, what you do, and what is your favorite dessert.
Yeah, hi, my name is Marco Ruckert. I'm the head of innovation for Surge Technologies, and my favorite dessert is cheesecake.
All right, then Andrew, please, over to you. Where are you calling from, what you do, And what is your favorite dessert, please?
Hi there. Hello, everyone. I'm Andy. I am calling from just south of London in the United Kingdom. I'm the Chief Solution Officer for Digital Towers for NATS, which is the air traffic service provider in the UK. We also provide services around the world. I'm actually not a very sweet tooth kind of person, so I'd actually say I pass on the dessert and go straight for a strong black coffee.
Good choice, I would say. And Jean-Philippe, my final panelist, please tell us where you're calling from, what you do, and what's your favorite dessert?
Yeah, so hi everyone. So my name is Jean-Philippe Poulin. I'm calling from Montreal, Canada, and I'm a corporate innovation manager here at Santec. So we'll cover that a bit later. And yeah, my favorite dessert is pure frozen mangoes. I just like pure mangoes.
Awesome. I love mangoes too. So we appreciate having all of you with us today and look forward to your presentations on the topic up for discussion. So during the presentation, you will be hearing people talk about the SDGs. So they are the Sustainable Development Goals from the UN, and there are 17 of them. You can check them out online, and I will be able to also provide a link to them in the chat if you're interested. So let's set the stage, and and to do that, we will play a short video. So Gino, please play the video.
So we are here at the meeting point between artificial intelligence, aviation, and the Sustainable Development Goals, and a lot of exciting things are happening. There are a lot of benefits we are seeing coming through AI, and we have really good panelists today to excite you about the subject matter. So there will be 2 webinars, the one that is currently running right now, and another one in August of this year. Information will be provided once a date is known. To get you into the mood and to get you into the subject, we have a short presentation. People are innovating around the world. There are telemedication, remote classroom educating the next generation that is happening. Those in need have access to what they need. The supply chain is more resilient and responsive. Knowledge to make all of this possible is being spread. So internet connectivity that enables telemedication, education, etc., is now being brought through the skies. Part of this is driven by innovation in aviation. AI has a potential to drive us further, and we want to imagine what we can do now that we have AI in aviation. Thank you. And here to show us the leading.
All right, thank you so much, Gino. So to tee up the conversation, I am delighted to invite our first speaker, Paul, who would make his presentation, for the benefit of the audience. And the presentation will explore the Fly AI report, which is a combined effort from Europe. So please go ahead, Paul, for your presentation.
Thank you, Mimuna, again. This time I'm not going to be talking any further about the desserts, and I'm going to present to you the results of a report that we wrote all together in Europe recently. Maybe one or two more words about my organization. I work for Eurocontrol, which is a European intergovernmental organization, and we're looking very much after supporting air traffic management in Europe. We are also having some operational units with a central flow management function, as well as we're running an air traffic control center for 4 countries in Europe. If we can go to the next slide. We, over the period from September of 2019 to March of this year, were running what we called a high-level group on European aviation artificial intelligence. It's perhaps a bit of a pretentious name, this high-level group, but what we did do is that we put around the table all the best experts and key decision makers from the policy level, from the European Commission, from the industry, from Airbus, from air traffic control organizations, from the airlines, from IATA, but as well from the staff associations, be them controllers, pilots, engineers, etc. We also included the defense people from NATO, European Defense Agency, etc. So we really thought we had the perfect mix of all the relevant players in European aviation and air traffic management. We wrote a report that we called Fly AI, and that very much concentrated on what is AI doing already today in air traffic management. We had 2 main objectives. One of it was to demystify artificial intelligence, because there's a lot of unknown elements around it still, as well as to try to accelerate the uptake of artificial intelligence in aviation, because we believe it holds a lot of promises and a lot of improvements and performance benefits for the whole of European aviation. The report was published on the 5th of March, literally a week before in Europe we went into the big shutdown. We had planned many rollout events, which unfortunately couldn't happen. So if you're looking for the report, first of all, at the bottom of this slide, you will see a link where you can pick up the report. But I also still have a few hundred of these paper copies that I'm happy to share with anybody who has an interest. Next slide, please. We didn't start from scratch, and we very much based our work and our report on the further work that's happening in the European Union on artificial intelligence, regardless of any domain. This is called the High-Level Expert Group on Artificial Intelligence, which published its reports over the course of last year, and they very much break down their recommendations over policy regulation, capacity building, and partnering. And you will see in our report that we have followed that same exact structure. Next slide, please. In the report, which I really ask everybody to download and have a full read of, we're first of all trying to demystify artificial intelligence, and that's why we call this AI is already in the sky. And we're giving you an inventory of all the applications that we found, be them either in exploration and R&D or already in deployment. We are finding in air traffic control centers, for example, already applications that are doing on a day-to-day business traffic prediction based on AI algorithms. We're also doing, for example, the monitoring of communication, navigation, and surveillance data that needs a lot of attention in Europe. We're also finding applications on runway occupancy, but our colleagues from Heathrow will further detail that later in the presentation. And in the middle of this slide, you see all the benefits, all the areas where we think that artificial intelligence is already today, or maybe already tomorrow, providing benefits to the greater good of aviation. And as you see, it goes into many different areas, going as well into resource management, workload automation, infrastructure managing, and even going to elements like spacing, separation, etc., although that will not be for immediate yet. Next slide, please. So the core of the document itself is what we try to do with the acceleration of artificial intelligence. And we come up with 7 steps that very urgently we think need further attention. The first step being that we need more sharing of data and a common artificial intelligence infrastructure framework. There's a whole plethora of tools and methods and processes, and we think that we can achieve a lot by sharing better our best practices and lessons learned. There's a big task to be done on research and innovation, but as I said as well, a lot of AI is ready to be implemented operationally or is already implemented, and for that we think we need further work on the tools and methods that provide us validation of artificial intelligence run algorithms. In terms of deployment, there are some areas where we think we urgently need to look at. For example, the cybersecurity domain. Cybersecurity doesn't stop at the border of aviation, and we really must make sure that we use the latest AI techniques to discover the threats on our area. We also recommend that in terms of deployment, we start with the non-safety critical applications, and we do the more delicate safety critical applications at a later stage. In terms of the recommendations 5 and 6, we also think that a lot of work is to be done in terms of communication, dissemination, training, and that training goes from top to bottom. We are training our senior managers, we are training all the staff, we are training our operational people. We really involve everybody we can think of in demystifying what artificial intelligence is and how it can benefit aviation. And the last recommendation is probably the most important one, is that we really should be working as much as possible in partnership. You don't do this on your own in a corner. It is something where we can really live and learn a lot from each other. And so we have a lot of practical recommendations on how to set up such partnerships. Again, I invite all of you to download the free report. The link is again at the bottom of this slide, and I'm willing to answer any questions you may have. Thank you very much.
Thank you so much, Paul. And I think that with that presentation, we are beginning to see the efforts that are being made by Europe to demystify and accelerate the use of AI in aviation. I think it's very interesting. I think it's also very interesting to see the emphasis on the importance of good data and infrastructure as well as the cybersecurity considerations that are being made, which is all very important for proper application of AI. So with that, thank you so much, Paul. And I will now hand over to our next panelist, Marco. Marco's presentation is on AI for air traffic management. He will talk about how AI has changed the way we develop systems from the engineering perspective and talk through a few use cases of AI for ATM. Marco, over to you.
Thank you very much for the kind introduction, Maimouna. As I said before, I'm the head of innovation for Surge Technologies. We are a leading technology provider for air navigation service providers and airports around the world. We focus mainly on digital and remote towers, but also on automation and decision support for air traffic controllers and airport operators. Next slide, please. The first point that I'm trying to make is that AI is a very accessible technology, and it also enables other technologies to be more accessible. And what I mean by that is that problems that we previously were not able to solve as engineers in our specific fields are now possible to be solved easier using AI and the underlying technologies such as machine learning. On this slide, I'm showing our very first video segmentation or video tracking technology circa 2010 on the left, and our latest AI technology on the right. It took us about 10 years to get to the point on the left. It was a lot of effort, taking optics PhDs and a lot of system experts to design this algorithm carefully, looking at the pixel changes and coming up with this algorithm. On the right, you can see the AI, and all we had to do for the AI is build on technologies that other academics and other technology companies have already built, taking it and adapting it for the aviation industry, showing it examples of different airplanes and being able to deploy this operationally. So the point I'm trying to make is that you no longer have to have a big team of technical experts in order to solve problems, but you can benefit from other technology providers and academics alike. The good thing about AI also is that it is by design noise resilient, so that you no longer have to worry about designing the algorithm for different scenarios. By showing the AI different examples of different lighting conditions, different aircraft, we're making the AI resilient by design for these noisy inputs. So overall, the AI really has a potential to speed up the system development and allow people who have traditionally not been able to access certain technology, access the technology now. Next slide, please. One of the most important things when we deploy these AI solutions operationally is ensuring that AI is safe. And that is from an overall system perspective and an end-to-end solution, but also specifically when it comes to AI, being able to understand where does the AI work, and more importantly, where does it not work? What are the failure modes? How does it fail? And how to ensure that the AI, if it fails, does fail safely. So what you can see on the slide here is we use the technique to understand what our AI here is interpreting as an aircraft. So you can see certain sections of the aircraft were blacked out. And in the top right corner of the picture, you can see the confidence score of the AI saying that there's an aircraft in the scene. So we can do this in order to understand what the AI is actually detecting in order to determine there's an aircraft here. And what you can see from the slide is that the fuselage is, for example, much more important than the wings. And the point of this is really understanding how to make the AI explainable, get everybody comfortable that the AI is safe. Also understanding that we don't have biases in our data, so that, for example, we only show Lufthansa aircraft and now all of a sudden it doesn't work for Turkish Airlines. So those are the things that we can understand by running these tests and really explaining AI and how it works. Next slide, please. So now I'm going to go through a few use cases of how we have developed this AI into operational solutions. The first one that I want to highlight is our shining star example of our cooperation with NATS. It's the London Heathrow Digital Tower Laboratory, and you can see on this slide, this is the overall human-machine interface of our system. You can see we have panoramic cameras in the top, we have a map display, and then in the bottom left corner, you can see our AI is monitoring the runway exits. So the tower in Heathrow is built almost 100 meters tall, and what happens sometimes is that the cloud cover comes low enough to block the controller's view of the ground, but the ground still has visibility, so everybody on the ground still has good visibility and operating in visibility conditions. So what happens then, we go into this 2 condition, and the air traffic controllers now have to rely on the ground surveillance system in order to clear the next aircraft to land, to ensure that the previous aircraft has exited the runway. So now we have to go from a very high fidelity surveillance source as the human eye to the ground surveillance, which means that we have to put a safety buffer in there and increase the spacing on final approach. This means we're losing about 20% landing capacity. And as a busy airport as Heathrow is, you can understand that that is a lot of movements. It's a lot of money that is lost, but it's also a lot of fuel that's burned by sending these aircraft to other airports or putting them into a holding pattern. Next slide, please. So what you can see here, to solve this problem, we have installed 2 cameras on 2 exits of the runway in order to try out technology. And you can see that the blue mask again is covering the aircraft. That's our AI detecting the aircraft. And what we can do now is visually confirm with this AI technology when the aircraft tail has left the runway, the white runway marker, and then again a safety zone, indicating to the controller, as is seen in the bottom in the aircraft tag, that it has now vacated the runway. And we can then indicate to the controller that it is now appropriate to clear the next aircraft for the landing. So what we have done now is we've brought again a very high fidelity source, which is the visual camera technology with our AI, where we can on a pixel level determine when the aircraft has vacated the runway. And what we are hoping to do is then bring back that 20% landing capacity and again, get the airport back to full capacity. We've tried this over for 3 months and now are building the safety case together with NATS to roll this out operationally in Heathrow. Next slide, please. The next example is from Dubai, where you can see that on the right, we're tracking not only the aircraft, but all the service vehicles around the aircraft as well, in order to automatically track the turnaround process of the aircraft. The aim here is to accurately track certain times, such as aircraft arriving, bags coming off, catering going on, in order to give information to all the relevant stakeholders to plan the turnaround process appropriately. So that would be airport operators being able to dispense resources such as catering trucks at the correct time. But what we also do is, based on historic data, give an early warning when things are not running as smooth as they should be. So that, for example, if we can tell an aircraft is arriving late and what the knock-on effects of that are, we can just, again, as an entire system overall between ATC and airport operator, dispense the resources appropriately to use all the capacity is so rare, the runway capacity to the fullest that we can. Next slide, please. The last example that I'm going to show here is our ground surveillance AI. So what we did here is we analyzed the year's worth of data in order to understand what the movement patterns are on the surface of this specific airport. And what we then were able to do is predict accurately what the trajectory of an aircraft is while it is moving in real time. So you can see on the slide here, we are accurately predicting the runway exits that this aircraft is going to take. What this allows us to do is accurately predict the runway occupancy time. Again, what we can then do is use the runway capacity to its fullest. If we can accurately predict the exit an arriving aircraft is going to take, we can then decide if we can squeeze in a departure in between two arriving aircraft, or can we, again, squeeze the final approach spacing. And I think that's it, and I would be happy to answer any questions later.
Thank you so much, Marco, for that brilliant presentation. And it's interesting to see how the use of AI could improve operations, especially in low visibility situations, and to improve efficiency and predictability. So that's very interesting. So thank you very much for that. The next speaker is Andrew. Andrew's presentation will provide information on the optimal solutions for airport air traffic control. So over to you, Andrew.
Thanks, Maimuna. So there will be an element of some of what I cover, which my colleague Marco from Sirius Technologies has spoken about. But I think that's quite relevant because it's a key part of where we focused. But what I want to do really is look at this from the point of view of how AI can really focus within air traffic control operations, specifically those at airports, to optimize what air traffic control is there to do. I'll try and make this as jargon-free as possible. Should anything be needing a little bit more of a clarification, by all means, we can cover that during the questions. But if we can move on to the first slide. I've included this one because it's 100 years since air traffic control was born. This is London's first airport back in 1920 in South London, in Croydon. And you can see front and center there, air traffic control is a key part of the operation 100 years ago in 1920. So it doesn't perhaps look quite as technically advanced as maybe you would expect when arriving at an airport. But certainly in the 1920s, this was the site to meet you as you arrived at Croydon Aerodrome. If we move on to the next slide, this is basically where we are today, certainly for London. And this is our main airport, Heathrow, 2020, so 100 years on. But the reason I've included this slide in particular is because while things are significantly more modern, and you can see that our shed has been somewhat improved in that it's now a 5-story glass building at the top of an 87-meter high stalk, very technological in the architecture and also in some of the systems that are inside of it. But effectively, the concept of operation from 100 years ago and operating Croydon Airfield from the shed that I showed you previously to moving to the control towers that we know and love very much these days, the actual concept of operation has not changed significantly. So you can see that it is dominated by the ability to look out across the airfield, which is obviously significantly larger than back in the 1920s, to accommodate significantly larger aircraft and larger numbers, and also larger numbers of passengers. But the underlying concept is basically a visual one, to look out and scan 360 degrees over an airfield, which may expand 4 kilometers or more in many or all directions, and also the skies immediately around there. And you can see that controllers still rely today on certain levels of technology that would have been recognizable by our forefathers in the 1920s. And you can see a controller there today holding a pair of binoculars to look out of the window because of the size of the airfield that we're surveying. So there's a significant similarity in operations for the last 100 years with technology supporting, and AI now is really the cusp that's going to significantly change our operations. So if we can move to the next slide, this is where I want to just start talking people through use cases. So I've included a few graphics here, and this is the use case that Marco was discussing before. But basically, you can see on the left-hand side of the picture, I've numbered a couple of graphics there. One is of a system which wasn't available in the 1920s, but is quite common in major airport towers these days, which is a ground surveillance system, a radar-based system using multilateration and also a primary radar, which provides us with a blip. So if you're looking at image number one, you can actually see very close to that image, there is a horizontal black line, which represents the runway on the airfield. And you can see a yellow blip, which is sort of aircraft shaped, and that comes from our primary radar. And then that's overlaid with a label telling us that it's a British Airways flight and where it's headed to, which is stand 561. The key of that particular system is to enable the controller to visually monitor the outside operation of the airfield when they don't have the benefit of the view that you can see in image number two, which is of this system sitting in the foreground, and then beyond that, you see the window out of the window view. And in fact, you can see, if you look very carefully there is an aircraft just underneath the number two, and that is actually on the runway, which is depicted in the larger image one. So primarily the controllers, as per the 1920s, will look out of the window and will observe the aircraft to clear the runway, and then ensure that the next aircraft can safely use that runway. So visual observations are key, but you can imagine that when those visual observations become difficult because of reduced visibility, low cloud in particular, which is common with today's modern tall control towers, that we then have to rely on the system above. Now, the one thing that I will say, when you look at the system above and you look at the aircraft in image one, you can see that it has a tail shape. You can see which direction it's roughly pointing in, and you can see that it has wings, although you can definitely tell from that radar image that, in fact, the whole of the aircraft is not entirely certain in its position that's provided by the system. So its tail crossing the little white box that you see and exiting the runway safely is why we apply an additional margin when we use a controller observing a system rather than observing directly out of the window, because the level of fidelity of what they're observing, particularly the aircraft, is lower. So we increase our spacing between successive arriving aircraft, and that reduces our landing rates. This is common at airports all around the world. It's not specifically a UK or a London Heathrow problem, but it is particularly of an issue at airports that are busy and capacity constrained, as Heathrow certainly was prior to the current restrictions in traffic due to the global pandemic. But that aside, you can see how the impact of a system limitation then brings in a procedural mitigation, which reduces flows and potentially has impacts, including those on fuel burn that Marco mentioned previously, and delays. So the system on the right-hand side shows how camera surveillance can basically provide us with an image, and there's an early image, in fact, using one of Sirius's previous AI models tracking an aircraft. But you can see how that aircraft can be tracked in image 3, right down to the last pixel of the little tail fin, and in fact the elevator that's on the right-hand side nearest to us as the aircraft clears the runway. So that's providing us with the kind of tracking that a controller would be able to provide on the best of days, but actually the one thing that it can provide us with beyond what even a nice day can give us from a control tower is the ability to see close up, because those cameras are distributed around the airfield, and the AI is able to track that aircraft while it's tracking another aircraft, which may well be behind the controller's field of view. So a controller normally sitting within the control tower has to move their head and look at various parts of the airfield, as well as looking down onto operational systems. So that involves, therefore, a human element and a scan that has to be built into the way that we operate. So effectively, if you can now bring artificial intelligence in such that it can monitor all areas in high fidelity in all conditions, that then becomes potentially a significant use case. If we move on to the next slide, this shows how we've deployed that use case at Heathrow. So Marco referred to a laboratory at Heathrow. This is in the base of the control tower. You can see the image there with, in fact, one of our operational controllers from Heathrow coming down from their operational position in the cab way above us and coming down to operate on the system that we were trialing for future operation within the control tower, using all digital, all video and integrated systems, which we've brought together so far in a two-phase environment. So the first one was actually establishing the laboratory, phase one, putting out the cameras for the artificial intelligence to be able to use along with the existing systems. And that's also involved an integration with those existing systems, including the radar-based one that I mentioned already, because this very much is a case of taking all available technology, not necessarily simply replacing what we currently have or replacing specifically humans. This is about improving the whole operation. So the second phase is all about a proof of concept for those enhanced operations, and that involved training the model. And then also the key to us from an implementation perspective is then doing validation of that with live data. So the controllers, such as the one you see in this picture, would have operated live and then come straight down into the laboratory and seen exactly the same situation, the same weather conditions unfolding in front of them, and work with us and the software engineers on the model training. But the model itself was allowed to run independently, and we have assessed more than 40,000 flights with regards to how well it's performing. And if we just advance on to the next part of this slide. So if we can just go to the next slide, that's it. Our results basically are showing us that Amy, the artificial intelligence engine from Seerage, and the software EAVD, which Amy runs with, has been confirmed from our validation that the cloud cover, the cloud height, aircraft type, the size of the aircraft, we call it its weight category, but basically the size and weight of the aircraft, and the airline operator, something that that Marco referred to earlier, has no effect on the impact of the system. It is effective in all those conditions. So regardless of the patterns on the aircraft, whether it's painted in the standard operator's color scheme, or whether in fact it perhaps has an advertising logo on it temporarily, the system can deal with all of these and the artificial intelligence can. So that's a key part of proving that the system is resilient for our operation. We've also looked at it from the point of view of fusing it with other information, the radar data, and we're now underway on a second phase of testing where we're looking at, because of its capabilities already, we're now looking at using it in much more difficult scenarios where, because of fog, the visibility has reduced below 500 meters. And that's the point at which pilots themselves have to rely on systems such as the Category 2-3 auto-land facilities of the aircraft. So we're certainly now looking at extending our business case and using it in a lot of further impacted scenarios. Another key thing for us is to prove that in heavy rain, strong winds, blowing snow, where that goes directly onto the camera lenses, that by use of fused data, we're able to show that the system mitigates those, and again, can be relied upon entirely by the controller. If we move on to the next slide, this effectively is just a graphic which is explaining overall the concept. So you can see our tower in cloud, and you can see that basically we're saying that the cameras are able to process the information faster than the radar update. Radar update is 1 update per second, whereas the cameras are updating at, in our case, around 25 times per second. So the system is more faster with its update rate, but it's also higher fidelity, as we've spoken about, with regards to direct pixels of the aircraft that are being observed by the system. And the visual element of that system, again, just being shown on this slide. So this is to aim to get back the 20% of lost capacity when the tower does go into cloud, but potentially there are further benefits if we can prove further that we can operate with AI doing the same job, but basically in much more reduced weather conditions. So my final slide, if we move on to that, there are further benefits of adopting artificial intelligence within ATC operations. And specifically, I see AI as being very usable in areas where human performance is limited. So the overload of controllers, so where workload becomes increased, then AI as support is a significant use for it. But also, I'm conscious at the moment that a lot of our airports are suffering from a downturn, which we're certainly hoping is temporary in its nature, as far as the significant impact it's had on the flights at our airports and through the international network. But the underload of air traffic controllers, where they are not working at their normal high workload rates, can actually have a negative effect with regards to human performance. So again, an AI system will simply be monitoring and processing the parameters that it has learned to process, regardless of the workload. So it can simultaneously scan in 360-degree view, and it can scan 2 aircraft simultaneously in opposite parts of the airfield, or it can scan multiple numbers of aircraft up to the normal sort of 100 or so per hour that we would anticipate through a major London airport. So that's one of the key areas. Also, improving efficiency of the infrastructure, particularly runway capacity, is a key area for us. And again, enhancing that efficiency of infrastructure means that we can do more with what we have already. We also have a benefit here where there is a limited number of things that a controller or any human can basically process simultaneously. And by being able to process higher numbers of parameters that affect outcomes, we can balance that to a greater extent, reducing taxi time and impacting particular outcomes with regards to some of the sustainability targets that were aimed for at the moment. So improved resilience all around. And actually, one thing which I'm sure you would have expected me to have mentioned, and clearly is a key part of this if we just go to the last part of this slide, but it is an important part on the next part, please, which is obviously all of this underpins an enhancement in safety. Now, our systems are very safe as they are, so it's always, I think, good to have safety where it's provided as an additional benefit, but it is not necessarily the first part we start the use case on, but we certainly ensure that the outcome of the implementation is as safe, if not safer, than our current operations. Mm-hmm. And that pretty much concludes my initial presentation. I'd be happy to take some more questions.
Thank you so much, Andrew, for that brilliant presentation. And I quite enjoyed the operational user cases for AI in areas of ATM. Quite interesting to see this software and how it's working, and the progression of the testing. It's also interesting that you mentioned that, you know, the intent of AI is certainly not to replace humans, but to enhance human performance, efficiencies, and to, at the end of the day, improve safety. So it is interesting indeed. So thank you so much for that. And please do put in the questions, put them in the Q&A section of Zoom as well. And we look forward to addressing all these questions. Thank you so much. So our last panelist, but not the least, is brilliant Jean-Philippe. So Jean-Philippe will be talking about empowering aerospace companies for using AI solutions. Over to you, Jean-Philippe.
Right, thank you very much, Manuna. So we've seen a lot of the awesome technologies, how it's applied in like really AI in the sky. I cheated a little bit. I'm trying to do the ground to the sky. So that's really, it's more from our point a bit what we're doing. So again, I'm Jean-Philippe Poulain, Corporate Innovation Managers. So going to the next slide a bit, very briefly, so to understand a bit the context. So I work for a collision lab at Centec. So really what we're doing and my role is to help corporations and even more like to consume an innovation ecosystem. That's really my role. So like connecting with like young startups and all that, and even universities, and even how to treat all that. So going to the next slide. So a bit what I've been seeing. So really I work a lot with just to understand like with like the big airplanes manufacturers, and as well as like all their suppliers. So that's a bit like just to put you in context. I know it's a bit aside of the aviation, but they have a big impact on that. So basically, the reason is we say behind, but it's not a bad thing at all. So it's because every solution, every technologies have an extremely high impact on everything they're doing. At the end of the day, like the life are at risk. So that's why like it's one of the point. Also, everything is built for resilience. At the end of the day, we're very happy about it. So when things works, well, we don't want to touch it too much because, well, it works very well. They've been working for decades. Even if I go back to Andrews, it's like even 100 years, the same thing that we're evolving and optimizing every single year. So that's why it's built for that. But it creates a big chain a bit like to the mentality, I would say, more the mentality, and also the general dynamics. Talking with some of our clients, basically it's okay, like they want to innovate and stuff, but at the end of the day, just everything is much slower in terms of from the sales pipeline all the way to applying contracts. We're talking about years and years to do everything, because let's say a contract can take, I don't know, 3 years to sign if it's not more, but after that you're good for 20, 30 years. So that's why also it goes a bit with the flow of it. And also the regulation, but again, like we're very happy that they're there. They're there for a reason, and it's to work with them. We've seen a lot of, it's great that the consensus, like we've seen at the beginning with Paul, it's great that the players are there, ICAO is there, all the entities are there really to sit down on the question and really to look forward. And I would say also the lack, but that's in every single domain, like the lack of cross-domain expertise. What I mean by that is either IT specialist, AI specialist, or data scientist specialist with a knowledge of aerospace, aviation domain specific. I would say like expertise is very hard because once it's a new technology. So basically it's very rare the people who have been doing that for decades. Usually they're actually professors. And after that, like to really go into the market. And for sure, most of them, it's a general. It's like very highly optimal old processes. I put it that way. It's more they really use a completely new way of building things, of designing. That's why a bit what Marco was saying, like kind of the new ways of designing, new ways. So it's kind of like to disrupt a bit that part. But again, it's very old, and because it's built for resilience. So it just again to put in context. So going to the next slide. There's a lot of hope though. There's a lot of strength, and we've seen all of them what they were saying. So, whoops, they all skipped. But so there's a lot of great the industry strengths. So because it's a very controlled environment. Okay, it's strange. It seems to have an animation that I don't know why it's there.
Second, so that it will settle. Sorry about that, Jean-Philippe.
No worries, but. It's kind of the industry strength that I want to say is there are a lot of different great stuff. So it's a very controlled environment. I can share my screen if you don't mind. Mm-hmm. Otherwise, I'll just a cappella style. That's fine. So controlled environment. So they have a lot of data. So everything is controlled because at the end of the day, they want to control the output. So, and they actually have a lot of ways to track everything. We go all the way down to manufacturing processing, all the way to all the fleet management, the flight when they went all across. So they have a lot of data. They have a lot of them. And it goes really from the entire supply chain of that. So that's very one of the big strengths of that. It's control environment. So AI systems, they love control environment because they know they can rely on that control environment. We've seen though in the aviation, like the fleet is like temperature visualization is not very controlled. I would admit that. So it's not as easy. But after After that, they have a very high level of documentation as well. So in every processes is documented because the industry asks them to do that. So again, we see like the regulation, that's the strength of that. So there's a lot of documentation that is like faulty, good, bad bills, measurements, maintenance, whatever. Everything that is going through different formats also of data. It can be like a report, images, video captures, and so many more. So the data exists, and because of the documentation, which is caused by the regulation. But that's a great strength of that industry. And after, there's a wide array of repetitive processes. So another great thing for AI system, so there's a lot of different events that occurs multiple times. So it's good for AI system to learn about those the multiple occurrences of different events, the good events or bad events or whatever events we're looking at. So that's another big thing that we can leverage in that industry. And also they have a wide range of variables. We've seen even like with Marco and Andrew, is even they're implementing new ones. So they're trying to complement enhancing like what is already there to enhance new sensors. So they have that capability to create different types of data. We call it like real world data, simulated data, a bit of mix of both, historical data. So there's a great mix of different type of variables that could very help building your feature system and really prioritizing towards that. So now we're going to the great opportunities that is already there. So we don't have to change to switch the slide. So all that to come. So what we've seen again, it's more a bit at a ground level. So a lot of potential is all about like the machine vision for quality control at every senses of the world. Like we can talk about it about the manufacturing, but at every step of the way, all the way to the airplanes. What we've seen a lot is because if we look more at the aerospace industry, there's hundreds of suppliers, for example, for one part. So, and they have to have the same processes or a quality system or quality assessment. So it's very good. So it's very scalable for solution, and they want always to automate. So this is, we work with those solutions for people. It can be from really especially defects detection that we see like through computer vision, and even other sensors, because they want to go deeper and deeper to really to categorize the type of defects, really to help. Because there's a lack of expertise itself, just in terms of quality control, it's an expertise in itself, and it's going lower and lower. After, we call it like predictive maintenance, but I would say even predictive analysis. We've seen great solution like application a bit before with Andrew and Marco about like a bit the predictive analysis, trying to assess what is there to different things. So that's a bit in that part, really to understand where we're going from what we know. So it can be at the fleet management level. It can be at just for purely like if we look at the Airbus of this world. So really to understand all the supply chains about it, like predictive, when should we do maintenance for different specific parts. We look at engines, we look at every single part. So those are the solutions actually we're currently working with. So it's really to look at different ways we can get there, so they better understand what's coming for them, and really to again do the great prediction towards that. After that, for sure, all the supply chain management. So I put it from the ground up. So yes, it can be just to supply from everything around the world, but also mainly to for how to assess and supply all the airplanes in the air, for all their own traffic as a company in itself, and in collaboration with others. So that's a hard part, but I want to get back to it. And also another great opportunity that we're seeing is all about like the chatbot for consumer experience. How that's really something they're looking for. If you look at the infotainment inside inside the airplanes, aircraft themselves, if you look at just purely from the consumer experience all the way through the journey of acquiring tickets all the way to their final destination. And so those are great opportunities that you actually were working with different partners. And also I want to, from the beginning, what Paul's was mentioning, it's everything through collaboration, because again, there's a lot of stuff that can be done. Young companies, and your talent is really what we're looking for. This is why, for me, my role is to know you all and actually help you guys to work with the big guys, because aviation is highly regulated, so you need a partner to get into that space. So if you have a solution for aviation, well, you better work with Marco, Andrew, or different entities like them, because and approach them, because they're looking for that. They want to get better every day, and you as a younger company or like a great new technologies, you need that platform to get in there, because you need the resilience, you need the security, you need a whole bunch of infrastructure that is very hardly doable. So for me, there's just a last note, like you can switch to the last slide basically, but we're always looking for new technologies, but at the end of the day it's a very stiff industry. However, they're very hungry to look now. It's like I've seen a lot of movement that everybody wants to get new solutions, and us we're there to help that. I know the other ones were extremely concrete, Marco and Dean, but that's why I went a bit up, because it's like I want to leverage what you guys have to offer. And even if you want to propose what you guys have, so like ideas and stuff like that, or things you work on in your research or anything, like feel free to contact me, and I'm pretty sure we'll find solutions for our great partners. So thank you very much.
Thank you so much, Jean-Philippe, and I do apologize to everyone, especially Jean-Philippe, for the problems with the slides, but you did brilliantly anyway without the slides. So we come to the next segment of the webinar, and this will now be the question and answer segment of the webinar. And that for this, I will be doing it in coordination with my colleague, Yuri Fatah, also from ICAO. So Yuri, do we have the first question?
Good afternoon, good evening, good morning. Thank you, Maimuna. So yes, we have quite a few questions, and I think safety is always first in aviation, so we can start with that. We're getting quite a few questions broadly on, how do we know it's safe? What kind of proof of concepts are we using? So what I suggest we do is the question can first go to Paul, so he has a greater overview from Eurocontrol, and then maybe our colleagues from working on that system in Heathrow can provide a few more specifics about how they did. So Paul, if you could generally cover, how do you build that trust and confidence that the public needs to know that this artificial intelligence applications are safe? Thank you.
Yeah, I think that's a very good question. I think first of all, as I mentioned in my presentation, we highly recommend that all layers in the organization are well trained, are aware about what artificial intelligence actually is and what it isn't. There's a lot of scares and fantasies and fears around it, and then when you sit down with people and you explain it, that it is just, I would say, standard analysis with just many more parameters than you would have in normal algorithms, then people much quicker understand it. And another thing that we definitely found out as well in the applications that we put operational in our own organization is to involve the operational people very early in the design process. It is not that the engineers went loose and came with a solution and then were then looking for a problem to solve. No, right from the beginning, we sat down with the operational people and we asked them actually, now what's the problem that you think that needs solving? And together, step by step, we built the applications in a very iterative and dynamic way. And I think those two things have proven to be really key success criteria for putting things into operation with confidence.
Thank you, Paul. So Andy, if you could provide maybe from your experience in your very specific use case, how you've applied perhaps what Paul has been explaining.
Thanks. Yeah, so first of all, I would agree with Paul entirely that involving the end users in the design process is a very important step, particularly right now because AI is not something in common use in aviation and particularly in air traffic control. And you'll have noticed in my slides that I mentioned straight off that the team of current air traffic controllers are invited into the laboratory facility, which we have put on site there at Heathrow for exactly that reason. So they can be involved in the design requirements and even down to how the system then interacts with them and what level of interaction they want. So we offered from the outset that if they wanted to see the video that the AI was being monitoring, that they could do that. And that was an early decision that came from the end users that no, they could understand what the AI was doing with that because of the demonstrations of it running live. And no, they didn't want that because that was just more information to survey and process themselves. So that was a good start, but I think it is key that you have that involvement. The other part is predominantly really in ensuring the safety of it, like any other system, and it's just a key part of that system. So that's why we've done operational data collection and validation to show how the system operates in different conditions, and we've done quite a lot of analytics. In fact, we had something like a 90-page report of the different parameters that were analysed as to how the system was performing. So from that perspective, it gives us a good grounding to be able to build a safety case as per our normal safety management system, which any air navigation service provider, that's their day-to-day. I think the other key to it, though, is actually demystifying AI from the point of view of it isn't some kind of strange being. It is simply a way of being able to program a system with algorithms capable of processing a huge number of parameters, as Paul mentioned as well, rather than manually inputting those parameters. And actually, I think Marco would probably step in and tell you how different the amount of time it takes to manually input parameters versus machine learned parameters. Then finally, the only other thing I would say around safety assurance is simply ensuring that you've got the system focused on a key element of your operation, because that way your machine learning is more focused, and likewise the ability to test that machine learning is focused. And the last part of it is simply we have used closed machine learned models. So once we've trained, the model is no longer continuing to learn within the operation. At this stage, I don't think we're at a position where we would be able to certify that type of system within our own operation. The levels of unknown would be too great. So I think simply by following those different steps, you can ensure that the system is as safe and in fact able to do more than a manually programmed system.
Thank you very much, Andy. Marco, since Andy had mentioned your name, would you like to supplement that with a little more information? Thank you.
Yeah, for sure. I mean, Andy and Paul already made most of the points that I was going to bring up. The only other thing that I would say is that when we design systems, it's important to know that the AI isn't running by itself in the operation. There's some logic, traditionally programmed systems in place as well for data integrity monitoring, for example, so that we can ensure, and I saw a few questions in the QA, how do we ensure, for example, that the data that we receive from the cameras, from the radar is good? So we have some integrity checking before it goes into the AI. But then more importantly, what we do with all our AI systems and all our systems periods is we have a dedicated safety module. The only responsibility of that safety module is to ensure that everything is running a smooth operation and make sure that before we present anything to the user, or in the case, for example, of our traffic light automation, before we send a signal to the traffic lights to change color, we have a certain safety check to say everything is running good. And it's the last final gate, as if a human would do, to assess some information, say everything is running smoothly, and then we can present that output to the user. So for example, we get a confidence output from the AI, and if something is not recognized to a high enough level of confidence, then we say, you know what, this is not safe to make a decision based on 75%, 80%. Then we can say, this is in a situation, running in a situation that it doesn't recognize, let's fall back to standard operating procedures and analyze the situation, do a root cause analysis, and come up with a corrective action to handle the situation the next time.
Thank you very much. So, Maimuna, in this particular question on regulation, one of the comments that we got was that the question on what the role of ICAO might be in terms of safety regulations. So you can either take that question now or when you wrap up.
So when we wrap up, I will do it when we wrap up.
Okay, thank you. I want to shift a little bit to another area of questions that I think is very interesting. And that is, so in aviation, traditionally you had to kind of build on top of the previous level of maturity you had of its infrastructure. You know, you went from nothing to slightly sophisticated to very sophisticated to highly sophisticated. But the question here that I'm seeing in some areas here is that is this new technology only going to be available to those who already have highly sophisticated systems, or is this leapfrog technology? Maybe Jean-Philippe, if you could start us off with the answer.
Yeah, no, absolutely. So, because us, we really work at very early stage, and also I want to do a bridge with what Paul was mentioning. So, a lot of people, they don't really know what it is and what it can do. So usually us, this is what we help them understanding enough so they can make business decisions. It's like we don't want them to be technical experts. So yeah, on that aspect, it can be a leapfrog. However, you need to have like a company with infrastructure to help you go forward. We've met a lot of younger companies with a lot of like great technologies. I'll tell you an example, like concrete with Thales Group, for example. They work with us for all the young companies. There was a great one here in Montreal, and it was called Air. And basically, what they were doing is really helping the resilience into 44 Titman, really picking up content and things like that. But they were not at all in the defense or no aerospace. So they tried, but for them was, oh, okay, that's too big for us. We're not very interested. And when they work with Thales Group, basically they help them to say, use our platform to be integrated in the airplanes, for example. So now that was like within 6 months, basically what it took for them to be integrated into aircraft. So I think it's doable. It's doable as a new solution to really skip ahead, but you need to have like the right partner that has the right data and right mindset as well. So I'm sure everybody who's sitting here, like it's kind of the partner you're looking for, and you want to work with them to make sure. But I think there's a lot of potential for younger ones. You don't need to use whatever that was built before, because it's kind of a new way of thinking as well. So I will stop there. I want the others to complement if they want to, but.
Thank you. Actually, so Andy, the technology that you were describing, is that something that could be implemented anywhere in the world, or is there a minimum, let's say, requirement that you look for before you recommend that it be used?
Yeah, it's a great question. So my view, actually, it looks at it in both ways, because I get major airports saying to me that they are just about to invest in or have just invested in some of the systems like the radar systems that I showed in my presentation, and they're worried that perhaps that was the wrong way to go. But my answer is simple, that whatever data you have is useful, and therefore having those radar systems, that data can be fused and used alongside of the camera data. Likewise, if an airport has existing camera systems, then you can take some of that data and either augment it with additional cameras, or you can simply use that. So I would suggest that if you have a use case for your operation, and that's a key, to make sure that you're focused on a use case which is valuable to you, then basically you then look at what you require. And it could well be that you have a lot of that information already. Some of the stuff we've done with Searage very recently has actually kind of looked at a fairly common area, which is voice communications, as being something which almost gives you a baseline. And again, if you have that voice data, then we're able to go through processing of that from the point of view of it being able to trigger specific outcomes or support for an air traffic controller. So I think really it's very much a case of look for what you need a system to do, and then do you have enough data? What do you need to supplement it with? But you certainly don't have to start as Heathrow or any other major airport to be able to take this kind of AI technology forward.
Thank you very much. And so I want to pivot a little bit to a question, and I see that Paul has already started to answer online. So I was going to ask Paul. So we have some questions on jobs, and how is the job structure going to change for aviation? It's a bit of an elephant in the room sometimes, but especially for the younger people who are about to get into aviation. Is there any guidance provided by your document where we can kind of see what the jobs of the future of aviation might be a little bit different or very different from what we see today?
If you want me to tackle that question,
yes,
what we identified in the Fly AI report is that certainly in the short to middle term, we don't see a massive loss of jobs in aviation because of artificial intelligence. What we do see, though, is a shift of the type of profiles that you need. And I think that's nothing new in aviation. Part of my career was working in aeronautical information and the whole ICAO NX15, etc., where we have moved from the paper-based AIP and the unreadable NOTAMs into much more digital systems and electronic and digital data sets, etc. Does that mean that we now have much less people working in AIS? No, this is not what we see, at least not in Europe. What we do see, though, is there are many more people, less people on the pure operational side, and many more with a technical background. All of a sudden, we have much more people walking around with a PhD in an AIS officer than we ever saw before. So, no, we don't think there's a major diminishing or decrease of the number of people, certainly not short term, but we do see the need for more skilled profiles as well coming into the business.
Thank you very much. And not so related, but I think somehow to Marco, if I could just ask you one of the questions that I see here. So the question is, what are the limitations? Or maybe an example of something that you thought would work, but then later you found out it didn't work?
Yeah, I think that's a great question, and I think it's a great point to make is that, and I think Paul has touched on this already, is there's a lot of good information out there, but there's also some bad information out there about what AI is going to do, and some of the stories, the Skynet stories, and it's going to take everybody's job. So I think it's important to say where we are right now with AI and where we're trying to go. And again, it's not to replace the human controllers; it is to augment. And what I, for example, an example where we have thought everything was going to work flawlessly is, as Andy mentioned, is the voice communication. So everybody looks at their Google Home, Amazon Alexa, and says, "Well, we're there. We can understand everybody's speech. Well, let's just automate all of the RT in air traffic control." Well, it turns out that the communication in air traffic control is quite hard to understand, even for you as a human. From me coming as a system engineer, no air traffic control background at all, listening to some of the speech, especially accident speech, is quite difficult, not only from a noise quality perspective, but also from the jargon accents all around the world. You have pilots from Dubai being trained in the UK, then you have Spanish pilots being trained in the UK. They all have different accents. So what we thought was going to be relatively easy is quite complicated because there's so many parameters, so much variability in the data. So I think that is an example where we thought everything was going to be easy, looking at the big tech firms and then realizing that the aviation problem is much more difficult.
Thank you. And perhaps, Andy, if you have some information to share with the group on, how long did it take to train some of this stuff? How much data was needed, and were you able to predict, let's say, the development cycle?
Yeah, well, the development cycles were set as we do whenever we do some of this sort of innovation type work, either in the UK or elsewhere, as fairly short turnarounds. And in fact, that was done because of the fact that we had the software engineers and the end users working directly with each other. So that certainly helps with regards to reducing cycles from sort of traditional industry approach to development of systems. But I think from the point of view of the model training, particularly if you have it in a safe environment like in the laboratory where you are proving, then it actually can turn around such that it can be a matter of weeks within sort of starting to actually having your first model trained, and then just literally test to see how it performs in initially a fairly high level number of different scenarios, be it sort of daylight, low visibility, what have you. And then once you've got that, there can be further refinements on the model. But I think the other thing also to bear in mind when you're looking at success is not to immediately take a failure as for what it is. So again, going back to when Marco was discussing about voice, when we actually we looked at the performance of systems set up, trained to take voice and convert that to text, there were some times where we didn't get a successful result, and then we put a human air traffic controller to listen to that transmission that had been received, and the human couldn't in fact make sense of what had been said. But the human air traffic controller on a regular basis during their working day quite often will say to a pilot, say again, giving the pilot the opportunity to rephrase, say more clearly, include a full call sign, whatever it may be that is the problem that caused the system, be it human or otherwise, to have an issue with it. So actually, when you start then looking at the system being able to make a similar request of a user to repeat, then again, you get an opportunity to rectify that problem. And it's simply then a case of determining whether the system is asking for too many repeats or whether that's kind of an acceptable level of sort of second request that it makes. So I think you have to kind of work through it with that in mind with end users, because again, the end user will often say, well, I can't understand that. I would ask the system to or ask the person to give me a further go at answering that question. So likewise, then stepping in, telling the software engineer, don't worry about that. Allow it to make the pre-programmed response. That often then ends up with quite a surprise as to how many times it's acceptable to make that kind of request. So I think it's work with end users and train and test in rapid cycles. So development sprints are really useful.
Thank you very much. So as a last round of questions, and I think we can ask this to all, in terms of the Sustainable Development Goals, improving the lives of people all over the world, do you have any specific, let's say, dream that you think that what you're involved with can have a good effect on the people, the societies in the world? So a little bit out of your comfort zone, I know, because we're very technical here, but feel free if you could just share some vision of how you think that what you're working on is going to help us as a community, beyond just never losing our bags again, let's say. So Paul, maybe you could start.
Thank you for that one. So how could artificial intelligence help us with world peace, basically? Okay, so thinking out loud, I mean, what do you need to do artificial intelligence? You need two things. You need, first of all, digital data, which increasingly become available. And I saw the question as well about Africa and the worries they have to roll out AI there, etc. I think this is feasible. It's very cheap nowadays to turn data digital, etc. So again, as long as the data quality is correct, you have one. You have the digital data. Number two, what you need for AI is CPU power. You need computer power. And if I see nowadays what my boy at university is doing with a Raspberry Pi, I think we're lowering the threshold for lots of people to do AI. And I think with that, we're starting to tap into the brains of many more people, certainly youngsters, who have a lot of bright ideas on how to improve the world and specifically aviation in our context, etc. So I would see it as a way, I'm an optimist, maybe naive, but I'm an optimist, and I see that this whole digitalization will make solutions and R&D available to many more people, and I'm sure good things will come out of it. Do I get away like that?
Thank you very much. And maybe Marco, if you want to supplement before I ask the other two.
Yeah, for sure. I mean, I've always cared very deeply about environment and climate change from when I was in high school all the way through university. So I think one of my dreams would be to help that sustainable development goal of curbing climate change and even reversing it in a way through use of AI. So we talked a little bit about Heathrow and how we can bring some of that landing capacity back, reducing the fuel burn. And that really comes back to the variability in operation. And that is something that is not only important for an airport operator in terms of a bottom line and everybody wants as an airline to get the same service every time, but it really reduces the overall fuel burn and really inefficiencies in the system. Aviation is like every other system. If you run it away from its steady state, normal operating procedure, you're losing efficiency. It's the same thing if you drive your car at a not correct speed or too high of a speed, you're burning more fuel. So what we're trying to do with this is really reduce the variability in the system in order to curb climate change and reduce fuel burn, but also noise pollution and things like that. So if you would say that is my dream in order to help just a little bit with climate change.
Thank you. Andy, you want to supplement that real quick?
So I would see the same thing. I would see that the experience of people within the system, the air traffic management system, so that's both the controllers and pilots, but also the passengers would see benefits in the same way that we've seen those as passengers going through airports and the use of technology, how that's changed over the last 5 years. It's significant. Once you get onto the air side and into the air traffic management area, that hasn't been as significant over the last 5 years, but I think there's a potential for that. And I'd agree with my colleagues that that can have an impact also from the point of view of being able to control a larger number of parameters means that potentially that can do anything from making something more predictable to also being able to manage noise more effectively and fuel and emissions.
Thank you. And Jean-Philippe, before we hand back to Maimouna.
Mm-hmm.
Yep. So it's a bit in the same sense about the environmental and climate change. Basically, it's more to control it. Just before to put the plane up, like everything that is under involves like a lot of different people, a lot of different companies. So there's a lot of movement before even building that plane, so that aircraft. So on that end, just still optimizing that part of it, I think would make a great change. A lot of it also on especially the core cities and stuff, and more in the philosophical part of it. It's more to understand like the new generation's value. And I don't know if AI could do that, but with all the social media and all that stuff, maybe if we can learn more value, see how we can actually leverage that the continuously evolving values of that new generation and take it to profit, basically, to the different causes we want to challenge. So that's
thank you very much. Well, Maimouna, with that, I'll hand back to you.
Yep, thank you so much for a brilliantly run session of question and answer. Thank you so much, Yuri. So one of the questions that Yuri asked was the role of ICAO in supporting the implementation of AI. I think ICAO can play a very important future role because one of the functions of ICAO is to provide sets of standards which will help regulate aviation across the world. In future, ICAO has a role to play in developing high-level standards that can be implemented by its membership to help regulate the use of AI. For now, this AI is not yet mature. There's a lot of discussions going on. There's a lot of research going on. And that ICAO participates in these things, like this forum, for instance. We're part of the discussions. We are part of other panels and other mechanisms to see how we could promote the use of AI, because it's very clear that the use of AI is very important. It improves efficiencies and it can be very beneficial for any system. So in short, there's a future role that ICAO can play, and one of these would be to develop high-level standards when the time is right. So with that, and before closing the panel, I would like to highlight some of the key messages and recommendations that were raised during the discussions. And some of these related to the establishment of data foundations and AI infrastructures. These are very, very important if you want to actually implement a good AI system. We've had discussions on the need to further explore the potential of AI in aviation and ATM, and that the communication element on AI is important for it to be enhanced, especially when it comes to the issues of demystifying the use of AI. We've seen a lot of talk about that, particularly from the presentation from Andrew. Also, we've discussed issues related to the aviation community that needs to build up an inclusive AI ATM partnership. This is very important, and that AI could be used to improve operational efficiency and predictability, especially in the ATM sector, even in flight operation, when you come to low visibility operations and so on. In another area as well, I think the development of AI in aviation should be pursued in a manner that leaves no country behind. We've seen some of these questions that have come from the audience, talking about some particular areas in the world, like Africa, where you have issues of infrastructure, issues of qualified personnel and so on. But whatever the case may be, to make it very useful, we cannot leave no country behind. We have to bring everybody with us. And there are significant uses of cases of AIs in aviation to help deliver on the SDGs. We've seen that in the ICAO video that we have we've shown, as well as the video that was, the presentation from Andrew as well. So with that, I would like to wrap up now and to say, finally, we have come to the end of our session. I would like to thank again our eminent and brilliant speakers for joining us today and addressing this very interesting topic. So thank you, Paul, Marco, Andrew, and Jean-Philippe for your brilliant presentations. I would also like to thank all the participants for the incredible participation and the thoughtful questions. I quite enjoyed watching the questions come in. 1, 2, 3. The excitement was interesting because it's a new topic. It's interesting. It's technology. It's the future. So it's been quite wonderful on my part, spending this hour or so with you. Please do stay safe. And thank you so much also thank you so much to the ITU team. And I'll hand over back to you, ITU. Back to you.
Thank you very much, Maimouna, and thank you also to ICAO for this session. It was a great pleasure hosting and presenting one of our first UN partnered sessions. A big thank you also to our panelists, as well to all the participants for making it so engaging and providing so many interesting use cases. Before we wrap up, I would like to highlight a few things that may be of interest to you. This Thursday, the 9th of July, we are very excited to partner with the Association for Computing Machinery, ACM, to present our first AI for Good keynote. Professor Sripak Patel is the 2018 recipient of the ACM Prize in Computing, and he will be here virtually. He will be here on Thursday to present novel perspectives for how ubiquitous computing can help improve our approach to healthcare and the COVID-19 pandemic. And next week will be a busy one. We have 3 webinars next week. 2 will be hosted with the X Prize Foundation and 1 with AI for Africa. So be sure to tune in. We're also posting the links to these sessions in the chat, and you can also find out more at any time on our website, aiforgood.itu.int. With that, we have reached the end of the webinar, and we would like to once again thank everybody involved, our panel, participants, partners, sponsors, and our co-convener, Switzerland. Thank you very much, and we hope to see you this Thursday.